Health is wealth. But what if our health takes away all the wealth we have? Let's look at the total US expenditure on healthcare, the money we have been spending on healthcare so far. It has been dramatically increasing every year and year. 2010, we spent about $2.5 trillion on healthcare, trillion with a T. And if we gonna spend with the same rate we've been spending, we're gonna spend about $4 trillion by 2015. Well, this is a huge amount of money. This doesn't concern me a lot if this amount of money is going into research and development. But let's see how this money, $2.5 trillion, is going. The $2.5 trillion that is going, 88% of the money that we're spending out of this $1 trillion is just taking care of sick people, nothing else. Just 2% is going on diagnostic, and only 10% is going on drugs and development. That's the cost of post-symptomatic medicine, when we actually know the person is having a disease. So what we really need here is early pre-symptomatic diagnosis. Well, everybody knows that early detection is the key to success here. For this, people have been looking for biomarkers. Biomarkers are basically an elements which is present in a normal individual and not in a disease, or vice versa. So what people have been doing here is screening a huge population against one specific element and scanning them, and then diagnosing or creating a marker as a disease. And then once they found out this, they're going for normal people or a huge population and finding that particular element and calling them as disease or normal. The wrong thing with this approach is we have spent like $30 trillion on this approach, 10 years, 20 years, and only 47 biomarkers have been approved by FDA till yet. The wrong thing with this approach is we are finding just a single element in a whole population. The population that we have right now is so heterogeneous. Nobody is all the same. One size cannot fit all. So basically a giant leap forward towards from biomarker to is biosignatures. Basically, it's different from biomarker in the sense that instead of looking one element in whole population, what we're trying to do is looking for 10,000 or other thousands elements at each individual level at a particular amount of time. So you have 10,000 different elements that we are regularly monitoring for individuals at a regular basis. So in that case, we're going to easily find out at what point of time some things that in your body is increasing or decreasing, and then can alarm you against a specific disease. Early detection is a gem, but the major challenge in early detection is you have so much cells in your body. Your body is huge complexity. And if you want to detect something at an early stage, the cells have to be produced in a very small amount because you are in early stage. Now the problem is, what are those cells which are produced in an early stage of a disease? And even if they are produced, how will you detect those particular small amount of cells in your body when you have so much amount of plethora in your body? So that's a basic problem. So basically what we need here is a magic element which is produced in our body at an early stage, and that is available in plenty, so we can detect it early. So that magic element that we found out is antibodies. Antibodies are basically just weapons that our body produces when it sees a foreign invader coming to us. So these antibodies are available in 10 raised to power 10 amount in your blood. And these antibodies are actually present in a very early stage, even before your disease starts showing up the symptoms. So even before you're catching up the flu or cold, or even if you sneeze for the cold, couple of days back, these bad antibodies are there in your system. We just need to get hold out of it and just let you alarm that you might be having a flu. But the bigger problem here is, as I said, antibodies are so much, 10 raised to the power 10. how are you going to collect those antibodies in your pocket or in anywhere? There are billions of them. So what people have been trying in the lab is taking a small glass plate, putting a bad cells, already known bad cells, as a bait in order to try and attract antibodies. And a drop of blood containing 10⁻10 antibodies sees these small bad cells, 85 bad cells or 90 bad cells, as a bait. And then only a specific part of your antibodies get attracted to this bait. And only subset like 500 or 1,000 get attacked to it. So basically what we need is a big fishing net. A big fishing net so that we can capture 10⁻10 antibodies in your blood. So in biology, what we figured out that this fishing net is actually can be made from taking the arms of the bad cells. So if you pull the arm of a bad cells and put it on a regular surface, you can do that. But the bigger problem is, do we know the bad cells? Do anybody know the bad cells for cancer? Does anybody know the bad cells for diabetes or Alzheimer's? No, we don't. We have no clue. So how are we going to solve this problem? So what we figured out is a remarkable invention here is introducing a random peptide chip. So what we did is, we don't know, ignorance is bliss. Let's take 10,000 different elements and probe them over a glass plate. And using this chip, we can get a signature of your system, your body, what we call as immunosignaturing. This is a generic term that we use quite often, but the process is very simple. We have a glass plate. Using some biochemistry, we probed 10,000 or 100,000 different baits, random peptides over this glass plate. And we apply a drop of blood. A drop of blood containing 10⁻10 antibodies sees these peptides as a bait and start attacking to the chip in a huge fashion. Now, in order to detect this binding, we have another antibody with a bulb fitted on it, so that this antibody recognizes this antibody, and then using a machine-readable platform scanner, we can detect as an image. And this image is a signature of your blood at a particular time of point, what we call as an immunosignature. Using this technology, we can screen thousands of diseased people suffering from cancer, flu, etc., and then create a pattern and make a smaller set of chip that can be embedded in your mobile phones or any other small devices. And then we can make a specific chip for each diseases. So one of the major breakthrough is immunosignaturing can be used for a specific diagnosis. A single drop of blood, you can put it on a piece of filter paper, send it on a mail, and we can receive this mail in a normal centralized system. These antibodies in your blood are relatively stable. So even if you're living in Arizona and you post it by email or a USPS, we're going to still receive it in a very perfect condition. Using this, we can monitor your health for a specific disease like type 2 diabetes, pancreatic cancer, or pancreatitis. And we can monitor day by day. And unfortunately, if we see something, we can email you and say, "Dear John, it's time to come to the lab. We have something to talk about." But the bigger problem here is, does anybody know what might be the risk? No, we don't know what disease we should monitor against. Should we monitor against ourselves against cancer? There are so many types of cancer, so many types of diabetes. I don't know, I'm confused. So what should I monitor against myself? I mean, there's so much of diseases. So what we did is combining these chips, small disease chip, into a general complication chip. So now we are a step forward towards from a specific diagnosis to a general diagnosis. A general diagnosis which nobody has seen before. People have always going to the lab for a specific things, but never a general basis. So what we can do with this chip is taking huge amount of people, having one chip in your pocket or in a centralized lab, monitor against your blood against this particular chip, and as soon as we find something wrong with the chip and this chip start giving a signal, then we get a signal that something is going on with your pancreas or certain organ or certain body parts. Then, from your permission, we can go and look for a specific disease for like type 2 diabetes or cancer and all, and we can then go for a specific diagnosis. So basic story, moral is, we have this technology which can be used as a tremendous achievable of diagnostic, using antibodies as biomarker, which can be used as a specific diagnosis as well as a total new concept introduced as general diagnosis of a regularly healthy people. Thank you.